So this is an old Keystone problem. It's a constructed response question that they've released for us to kind of see and practice with a little bit here. And so we'll have our little review quiz on Friday that'll be based off of this question. So if you read what we're told in the paragraph that precedes what we're actually asked to do, it's telling us two people are at a carnival. At this carnival, the people there earn tickets while playing different games. The tickets can then be turned in for prizes. I've already highlighted this, and this is pretty much the most important part of the problem statement. It tells us how many tickets Tom earns for every time he plays two of the games that are at this carnival. He earns 5 tickets every single time he plays ring toss, 3 tickets every time he plays the fishing game. Sally, on the other hand, is only going to earn 3 tickets when she plays the ring toss, but then 4 tickets when she plays the fishing game. It goes on to say that Tom needs to earn at least 15 tickets for the prize he wants. Sally needs to earn more than 12 tickets for the prize that she wants. Part A asks us to write a system of 2 linear inequalities. So I read that phrase right there and I realized I needed 2 of something. So we know in these constructed response questions they're worth 4 points. If one of those pieces of a problem asks you to do 2 things, that piece is going to be worth 2 points. So you definitely better be writing 2 linear inequalities, and system is just more than 1, right? So that they could have, I guess, been a little bit mean to us and told us to just write a system of linear inequalities, but they were nice and they actually told us how many we need. So we want a system of 2 linear inequalities. I read this word right here, and what that triggers for me is greater than, less than. I don't want equal signs in whatever I write, so that's the key to identifying this word there. We want to model the number of tickets Tom and Sally need to earn based on the number of times each plays the ring toss, and they tell us what to use for the number of times they play the ring toss, X, and they also tell us to use Y for the number of times that they play the fishing game. So I read that and I kind of went back and I labeled the number of times we play ring toss as X, number of times we play fishing as Y, same thing for Sally. And I realized, okay, for my linear inequality for Tom, he's going to earn 5 tickets every time he does the ring toss. So how many tickets is he going to earn if he plays the ring toss 5 times? Well, 5 times 5. Well, what if he only plays the ring toss X times? He's going to earn 5 times X. I'm going to add on the number of tickets that he's going to earn by playing the fishing game. He gets 3 tickets every time he plays, so 3 times the number of times he plays is going to represent the total number of tickets he earns from playing these 2 games. I went back and I kind of reread this. It says he wants to earn at least 15 tickets. So he'll be happy with 15. He'll also be happy with more than 15. And that told me the total number of tickets he earns has to be greater than or equal to 15. Now, on the other hand, Sally is going to play the ring toss X times. So the number of tickets she earns from playing the ring toss is 3. So 3 times however many times she plays the ring toss plus 4 tickets times however many times she plays the fishing game. Here's the total number of tickets she's going to earn. It says that she needs to earn more than 12. It doesn't say at least 12, it says more than 12. That tells me that I can't have the equal to piece on Sally's inequality. I need the total number of tickets that she earns to be greater than 12. So those are the 2 inequalities that you need for the system to be correct in part A. We're going to definitely use these again in parts B and C, so you'll see these reappearing on the next few screens as we move on to the next pieces of the problem. And so if you read part B, it says what is the least number of times Sally needs to play the ring toss in order to have enough tickets for the prize she wants. Ring toss is X, right? They told us that in the first piece of the problem. And if she's only playing the ring toss, what I realized right away was that Y is going to be 0. She's not going to play the fishing game at all. So what I did is I took Sally's inequality from that first screen, the one that we came up with at the bottom of part A, and I realized that if she's only going to be playing the ring toss, Y is going to be 0. So I put 0 in for Y. 4 times 0 is 0. That just leaves me with 3x. If she's only playing the ring toss, if she's only playing X, the inequality that I need to solve to figure out how many times she's going to have to play in order to get the number of tickets she needs is going to be this. So I went ahead, I should have shown this step. I divided both sides of this inequality by 3 to get X by itself. And after I divide both sides by 3, I get 4. So X has to be greater than 4. Now, reread the question. It says, what is the least number of times she needs to play only the ring toss in order to get the number of tickets she wants? This says X is greater than 4. if she only plays 4 times, she's going to have the equal to 12 situation that arises. There's no equal to piece on this inequality because of what we saw in part A. It says she wants more than 12, right? So I know that x has to be greater than 4. So what's the fewest number of x's that are greater than 4? Well, 5. She's going to have to play at least 5 times the ring toss only in order to earn the number of tickets that she wants. Part C is kind of similar. It says what is the least number of times Tom needs to play the fishing game in order to have enough tickets for the prize he wants. And I guess I forgot to read this little sentence that was above where it actually listed part C. It says Tom's going to only play the ring toss 1 time. Ring toss is X, so he's going to get 5 tickets from that, right? We're basically going to be putting 1 in for X in our inequality. After that, he's only going to play the fishing game. So what's the least number of times he's going to have to play the fishing game after playing the ring toss 1 time? So what I did is I realized, hey, X is 1. Putting 1 in for X is going to mean he's going to get 5 tickets from playing the ring toss that 1 time, and I need to figure out what my answer for Y is. So I'm going to subtract 5 from both sides of Tom's inequality from part A. That's going to give me 10 on the right-hand side. I have 3Y on the left. I want to know what my answer for Y is, right? I want to know how many times he's going to have to play the fishing game. So when I divided both sides by 3 to get 10, to get the Y by itself, 10 divided by 3 got me 3.3. Well, again, it says the least number of times. I can't play 3.3 times. If I play 3 times, I don't satisfy this, so he doesn't yet have enough tickets. But if I play that 4th time, that's the least number of times I'm going to be able to have this statement right here being true.